Hi everyone, I'm Elaine. My research this summer was about why AI systems still struggle to answer questions from financial filings, even when the answer is technically present in the documents. This project started with a common assumption in RAG development. If retrieval is weak, we can improve it by using better chunking, re-ranking, metadata, query expansion, or a hybrid system. My main result is that this assumption mostly failed on SEC filings. I tested 7 retrieval configurations on Financial Bench, and the strongest conclusion was that not one clever retrieval technique won. The stronger conclusion was that the underlying document representation was broken, especially for financial documents and tables. Um, it is easy to say that the GPT is bad at reading financial documents, but several stages happen before the model ever sees the evidence. A filing is parsed, split into chunks, embedded, searched, and only passed to the uh, language model at the end. My project found that the biggest failure often happens early in this process. Financial tables contain headers, row labels, years, units, and signs, and need to stay connected. And when chunking process separates these pieces, retrieval searches over the incomplete fragments. At that point, a re-ranker can only reorder broken fragments. Query expansions can only search from those broken fragments more creatively. A stronger language model or a better retrieval strategy cannot reliably answer questions from evidence that was never perceived correctly. So for this experiment, I compared 7 conditions. Um, they are first of all, it's the baseline testing, and then there's semantic chunking, recursive chunking, cross-encoder re-ranking, metadata enrichment, high query expansion, and a full hybrid configuration that combined um, multiple of these methods. This design matters because if I only compared the baseline with the individual or with the full hybrid, I would not know which component helped and which component hurt. So conditions C1 through C5 isolate individual retrieval choices. C6 asks for a more realistic engineering question. If I combine several or multiple retrieval stacks, does the system finally become a lot better or is more efficient in this process? And the answer was surprisingly close to no. Um, for the design of this research, the benchmark was a finance bench, which contains questions over real SEC filings. The original evaluation had 150 questions. I only used 133 because a source of the 17 questions could not be retrieved for this research. The questions fall into 3 categories. Metric generated questions are often numerical, novel generated questions test more varied reasoning, and domain relevant questions resemble the kind of like qualitative questions that an analyst might ask. I evaluated each condition under 3 main sources: RUGL, exact match, and latency. RUGL is the standard overlap metric used in Finance Bench. Exact match checks whether the correct answer appears anywhere in the output, which is very useful for short numerical answers. Latency captures the operational cost of adding more stages to the pipeline. So the core result of my research is that there is no meaningful improvement using a different uh, retrieval strategy because across all 7 conditions, the entire RUGL range was only around 0.017. The baseline achieved a 0.177, and the hybrid, despite combining multiple retrieval strategies, achieved a 0.78. It is an improvement by only 0.001. So none of these enhanced conditions produced a significant improvement over the baseline. This matters because the hybrid is the exact system many teams would build when trying to strengthen the RAG system. It includes larger chunks, metadata, plus dense retrieval, re-ranking, and query expansion. But in this experiment, adding those components mainly increased complexity and latency rather than accuracy. The result is negative, but it is very useful. It is telling us that retrieval optimization is sometimes not the main bottleneck, and this prevents us from investigating further in the wrong direction. Uh, this slide combines accuracy with latency, which makes it clearer for us to see where the trade-offs are. Recursive trunking, which is the second method, is the only enhanced condition that is matching with the baseline's RUGEL while keeping latency almost identical. Semantic chunking and re-ranking are both around 3 times slower than the baseline. The hybrid takes approximately 50 seconds, which is around 4 times slower. Even though the hybrid technically has the highest RUGEL score, it is not very efficient. The improvement is negligible, and the exact match score is actually worse. Semantic chunking is an important exception. It is slower and performs worse under overall RUGEL, but it produces a very strong result for exact match. This is just that semantic chunking is not necessarily better, but it might be useful as a specialized route for numerical questions instead of just regular questions. Here are some of my main findings from this research. Finding one is that the hybrid is inexpensive ornamentation. So this pipeline looks sophisticated, but it does not address the real failure in the retrieval process. The hybrid combines recursive trunking, metadata enrichment, dense retrieval, cross-encoder re-ranking, and high-query expansion. It achieved the highest RUGEL score, but it is only an improvement by 0.01. It also has the lowest overall exact match score and the slowest latency. So the pipeline performs much more work without delivering a very meaningful accuracy improvement. The broader engineering lesson is that we should not be stacking strategies and just different ways of retrieval automatically. We should evaluate each stage more carefully before adding everything up together. The second finding from this research was RUGEL highest numerical accuracy. So in the first place, we were only looking at RUGEL to find the accuracy between the result and the base documents, but semantic chunking has one of the lowest overall RUGEL scores, but achieves the highest exact match on matrix-generated numerical questions, which means that selecting a retrieval strategy using RUGEL alone would produce the wrong recommendations for different types of question answering, especially for numerical financial question answering. For example, a model may correctly calculate the number 24 for this question, but the explanation is different and the wording is different. So then the RUGEL score would be a lot lower than we expect. But also, just looking at exact match is also imperfect. It does not confirm that a member exists in the right context, unit, or assign, but it reveals an important signal that we should be looking at RUGEL and exact match and also other things to measure the accuracy of our results. The third finding was that metadata enrichment is very unstable. After running a few seeds of the fourth experiment, which concerns metadata enrichment, I found that it is very unstable throughout the stages. First one had a score of 0.161 and it dropped to 0.146 in the third one. It is likely because that the tokens can dilute or destruct the semantic embedding signal, depending on like the stochastic behavior of the retrieval and the generation pipeline. But it just shows that a single run RAG evaluation can be misleading. A component might look very unhelpful, mildly unhelpful under one run and actively damaging under another one. So why did this system fail? Financial documents and financial tables are not simply collections of text. A numerical value only makes sense when it remains connected to its row label, year column, or unit. PDF text extraction and token based chunking frequently separates those elements. For example, a query asking a capital expenditure in fiscal year 2022 may retrieve chunk containing capital expenditure, but not necessarily retrieving connecting the 2022 to that value. Alternatively, it may retrieve a sequence of values without like table later table headers, labels that identifies what it's connecting to. So I think um, when that happens, the answer is no longer available, and the model is uh, not viewing this evidence as concurrently as possible. So re-ranking cannot reconstruct the original table. I cannot reliably infer the missing row column relationship. So the approximate fix is table-aware parsing that preserves financial documents as structured objects for future research. Um, yeah, so there's no evidence or explanation to see where exactly the pipeline failed, but a question can fall on PDF parsing, chunk creation, re-ranking, answer generation, or evaluation. Um, if the table is already fragmented, then even a very capable retriever or re-ranker has little chance of recovering the answer. So a better evaluation system would save a detailed trace for every question. That trace can include the original extracted text, chunk ID, retrieval ranks, retrieval re-ranker score, the context passed to the model to generate an answer, and the metric results. Um, by building a system and evaluation system like this, we would it would allow us to clarify failures by stage rather than testing the whole RAG pipeline as one black box. So from this research, there are some practical recommendations for using which strategy for retrieval, just based on like the numbers that I got. For general Rugal performance or low latency settings, baseline or recursive chunking is sufficient enough. Recursive chunking is a safe alternative because it matches the baseline's F1 and has ideally identical latency. For numerical questions, semantic chunking is a strong alternative. Uh, it has the strongest result under exact match, but I would investigate further to see if it is a great strategy or it is just an evidence that numerical questions should be separated from other questions to have a better result in retrieval. My research found that C4, which is metadata, and C5, which is query expansion, both has low accuracy and like unstable across stages, so shouldn't be used uh, uh, shouldn't be used too much. But the most important recommendation is to invest a upstream to investigate how we could parse the tables more efficiently before any adding more retrieval techniques. So future work, the future steps of creating a better system um, would be first change the document representation, um, can change the financial tables to be more extractable or changing the system so that we can preserve headers, row labels, values, units, years, and page references within a financial table. The second step would be question type routing. We should separate numerical questions uh, from qualitative questions, and then see if different strategies work better on different types of questions. And finally, I would introduce controlled stress tests. Examples include removing table headers, shuffling year column separating rows, changing units to see if where the retrieval has gone wrong. Yeah. To conclude, the main lesson here is that bigger RAG system is not automatically better. Um, a automatically better RAG system. I've tested 7 common retrieval improvements on none significantly outperformed the baseline under Rugo. The full hybrid was visibly slower and did not improve exact match. Semantic chunking was one that was useful for numerical questions, but we should evaluate further using different tests and further testing. Metadata enrichment was very unstable across like the tests, and the next version of this research should make this the evidence object more explicit, preserve table route questions based on their types, save detailed traces, and stress test the pipeline against the exact document that it is expected to handle.